Hi, I'm Charles He, and welcome to Patient Like Me Team Firepower Deliverable 2 presentation. With me is Carrie Gunter. We're going to be taking you through D2. So quick agenda, we'll go through our project plan, look at our architecture diagram, go through the tech that we are using and thinking about using. Carrie will take us through the data sources, the concerns we've noted, and our mockups. Quick look at our project plan, a couple of callouts. We are still about to complete the decision on our technology stack. A couple of items we've noticed in the data set that we have so far, and we're looking to get more data from different data sources. From an architecture standpoint, we have two options. We can either directly call the database, which contains the patient information, do some initial processing, finish the processing, and serve out the data to the physician or caregiver via a web interface. Or we could leverage very similarly, but have a database call done through the FHIR APIs. Again, the FHIR API will proxy the database call. We'll do processing as well as similarity matching and eventually serve the data out to the physicians or caregivers via the web interface. In terms of our technology stack, we have confirmed and decided on Java as our team's preferred language. We'll be using Spring and Bootstrap for web interface. Maven, Jenkins, and Docker tend to be for our dependency management, building, and hosting the runtime environment. Obviously, the data will be in Postgres, and GitHub is standard for source control. Additional tools that we're evaluating is Terracotta Big Memory or Redis for in-memory caching to speed up service speeds, Weka for machine learning framework for similarity matching and algorithms, Sufi and Patternfly for dashboarding on our interface, and Java persistence APIs for database communications should we choose not to use the FHIR API.
All right, let's talk about data sources a bit. So we looked at one data source being the MIMIC data set. It has about 40,000 patients. It's de-identified health information. It's got about 31 million observations and about 500,000 conditions. This spans about 12 years. It's a decently large data set, but we're hoping to look into larger data sources and leverage them. There's a data source that contains about 2.3 million patients and would help us to expand the scope of our project. The system is planned to support multiple users logging in and out, although there's not planned to be any core functionality difference when one user logs in versus the other. We anticipate that one physician will have the same needs for looking at similar patients as another physician will. One of the biggest issues that we have in our project is that these data sets are very sparse, meaning that there are a lot of features and one patient may only have a couple of those features. So in comparison to the sparseness of the data set, we don't have a lot of data. So we would like to look into using more data, but comparing all these features in a larger data set could be very slow if we're doing it naively. So we'd like to use a nearest neighbor model to make the matching faster. Nearest neighbors have been known to not work very well on sparse data sets, so we'll also be looking into an approximate nearest neighbors algorithm that'll give us an approximate result that should work better on a sparse data set. We'll also have to look into the heuristic that actually determines the closeness of two patients. We may find that one heuristic is better than another, so we plan to do much experimentation on multiple heuristics. These are our project mockups. On the left, we see we have the current patient and a matched patient. The attributes would be grouped around the physiology of whatever the body part that was related to the attribute. The color would relate to how closely the attribute matched with the found patient. So green would be a very high correlation and red would be very low. On the bottom right, you can see the attributes listed with their correlation. And in the top right, you can see a pie chart of how much the matched patient matched with the current patient, as well as the distribution of the different attributes and the amount that they matched. This has been our technical deliverable D2. Thank you for listening.